All right, 6.4, the fundamental theorem of calculus, part 1. Clearly this is an important section for just calculus in general, because we're finally putting a few things together in terms of integration and an easy way to do it. And we kind of talked about this method in the last section, and I showed you that this in class. If a function is continuous on the closed interval a to b and capital F is an antiderivative of lowercase f on the interval from a to b, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. So you just find the antiderivative the way we did in section 1, and then from there you plug in the upper limit minus when you plug in the lower limit. That's your answer, okay? That's all we're going to be practicing for now. Some of you might be asking, like, why aren't we using plus c? Where did plus c go with our antiderivatives? Well, because these are definite integrals, we don't need to put plus c, because if I'm subtracting these two and I have a plus c at the end, c minus c is 0 and goes away. So no need to put plus c when it's a definite integral. Just when it's an indefinite integral, we need the plus c. So we got two examples right here that we'll do together. They're not always going to have a lower limit of -1 and upper limit of 0, but this is what we have for this one, okay? So let's evaluate the integral. That's what we need to do first. So we're going to get 2x to the power of 2 divided by 2 minus x. X is the first divided by 1. 2 divided by 2 is 1, so we just get x squared minus 2, so x squared minus x, rather. And we're evaluating that from -1 to 0. We put 0 in, you're going to get 0 squared minus 0. Put -1 in, you're going to get -1 squared minus -1. And then we get 0 minus -1 squared is 1. 1 minus -1 is 2. So you're going to get an answer of -2. Cool. And then for this one right here, a little more complicated because we have a fraction, the exponent. So you're going to get t to the 4/3 divided by 4/3 minus t to the 5/3 over 5/3. Once again, it's from -1 to 0. So when we divide by a fraction, it's going to be, you're going to flip the fraction and make it multiplication. So 3t to the 4/3 over 4 minus 3t to the 5/3 over 5. We put 0 in, it's just going to get a 0, right? 0 to any power is going to be 0. And then you multiply anything by 0, it's going to be 0. So 0 minus, we put -1 in though. -1 to the 4/3 will get us 1, and 1 times 3/4 is 3/4. Minus -1 to the 5/3, which will get you -1, and then negative times 3 over 5 is going to be -3 over 5. We subtract them, there are two subtraction signs, so it becomes addition, and we are going to get, if you get a common denominator of 20, you're going to end up getting 27 over 20. 0 minus that, so it's going to be negative that. All right, we need to do an absolute value example with these. So when we have an absolute value, what we need to be thinking about first is what makes this 0. All right, decide what makes inside of ABS value 0. Okay, and that number is 5/2. Okay, if you decide to go to 0, you get 5/2. So what I'm going to do is I'm going to set this into two different intervals. 5/2 of 2x minus 5 dx, and 0 to 5/2 of 2x minus 5 dx. Now, this one right here will make it negative, so will make the inside of the absolute value negative, so we put a negative up front. Okay. Now we actually integrate. Okay. And we're going to be using our fundamental theorem of calculus as well. So when we integrate, you're going to get x squared minus 5x for both of them. The only difference here is we're going to get a negative x squared plus 5x for this one. And we are going to evaluate it from 5 halves to 5 and 0 to 5 halves. Over here on the left, when we put 5 in, you get 0. You get 0 minus, when you put 2.5 in, you get negative 6.25, which gets you 6.25. Over here, we go from 5 halves, which is 6.25, minus, put 0 in, you're going to get 0. It's going to get your answer 6.25. We add up whatever our answers are, and then we're going to get 12.5, or if you like fractions, 25 over 2. Either one works. Here's the mean value theorem for integrals, okay? If f is continuous on a closed interval from a to b, so f continuous on the closed interval from a to b, then there exists a number c, there exists c in the closed interval such that the integral from a to b of f of x dx is equal to f of c times b minus a. Okay, very similar to the mean value theorem when we did derivatives, right? Just saying that there is a c value that there exists in between the integrals. This formula right here is called the average value of the function. Average value of a function. On an interval, I should add. Okay, so we have our basic integral that we've done before. We find the integral of this, and then we multiply by 1 over b minus a, b being the upper limit and a being the lower limit. We will do some examples, and the same rules apply. We can integrate f on the closed interval a to b. And the average value function is this. So we have an example of f of x here being equal to x minus 2 square root of x, and integral 0 to 4. So I'm going to have 0 to 4 of x minus 2 radical x. So outside of it's going to be 1 over 4 minus 0, which is 4. So we integrate it. You get 1/2 x squared minus x to the 3 halves times 2 over our new radical, which is 3 over 2. And we're evaluating that from 0 to 4. Let's simplify. You're going to get 1/2 x squared. When you flip the fraction and multiply, you're going to get minus 4 over 3 x to the 3 halves. From 0 to 4. From 0 to 4, it's going to make it 0. But when you put 4 in, you're going to get a negative 8/3. Okay? So it would be negative 8/3 minus 0, which is negative 8 over 3. Okay? And remember, we have to multiply that by 1 over 4. So your average value would be negative 8 over 12. And that reduces down to what? Negative 2/3. So the average function, as we said, is negative 2 over 3. And it might also ask you in the directions to find all the values of x for which the function is equal to the average value. So what we would do is take this negative 2/3, put it in for f of x, and then solve. You may use your calculator for that to figure out when they would be equal. I believe there are 2 values in this case. So that's everything for so far in 6.4. There's a part 2 coming up later. I appreciate you watching, and we'll see you later.